Morning, everyone. Actually, good afternoon. I'm Francis, and I'm going to be co-presenting with Jing. So maybe
Hi everyone, I'm Jing.
cool. So we can do the collection and some of the ways in which you can be able to use the structured data capture to be able to help you in managing the data, collecting the data, and eventually using it as FHIR resources. Next. So essentially, I believe a greater percentage of the implementers who are currently working in the local setups, at least in the LMICs, have encountered this before, how to go about at least collecting data from a community-based setting. So here we're just looking at how can you be able to bring care closer to the people who mostly need it. So here we're looking at the different CHWs who are working in very remote areas in desperate regions which ideally need care more than others. So for this, we're looking at how can you be able to efficiently collect the data, be able to structure the data, and eventually use the data in a meaningful way that can be able to bring either more insights or provide the critical care that these people need. So examples of the use cases where at least this will be used is either when you're going to collect data about these people, so ideally doing the first point of entry, which is registration, and then you have some examples where you're doing things like ANC or PNC, follow-up for mothers, so this is before and after. Then we have intervention tracking where we're looking at services such as electronic immunization, reporting and recording for either children or in the modern use cases such as adults for COVID. And then lastly, doing some form of data integration where at least you want to make more sense of the data that you're collecting. So with this, one of the key challenges that you're trying to solve by using the specification is moving away from at least the paper-based to a more centralized and digitized solution through the SDC, be able to ideally capture the data and at the end of it make the data more portable and useful. So how does FHIR help this to bring it all together? So I'll have Jing walk you through this.
All right, thank you. Can I have the clicker? So we talked about sort of earlier on this morning, we talked about sort of implementation guides, which are sort of collections of resources that sort of define how you should solve a particular problem. So here there is a implementation guide called structured data capture. This is the IG for sort of defining the operations and the extensions that you need for structured data capture process, right? So this is also built on some basic FHIR resources, for example, the FHIR questionnaire and the questionnaire response resources in the base spec. So the difference between these two sort of layers is that the FHIR base spec sort of defines the forms and answers and the format of the data that you'll be using in the SDC. And the specification, the IG, defines the operations that built on top of the data. So let's first take a look at FHIR questionnaires and FHIR questionnaire responses. So a FHIR questionnaire essentially defines a form. It is a collection of questions in a very structured way, and each question would have a unique ID, so you can refer back to the question. You will have a data type, you have text, answer options, etc., etc. You will also include some information about rendering, like how do you actually paint this form and how do you paint each question on the screen to make it very easy to interact for the users. You know, whether the questionnaire is paginated, whether it's a single page, a long scroll, and some of the more advanced behaviors such as skip logic So that is when you try to hide or show different questions depending on the answers you have given to previous questions. We'll see more examples a bit later. And the questionnaire response is essentially the resource that captures the answers in the form, right? So each answer is linked to the specific question by the unique ID we just mentioned, and it can be further converted into other FHIR resources in the process of data extraction. I think I've actually covered some of these behaviors, so I'm not going to go into too much detail. Yeah, I think perhaps one couple of things to highlight here. One is form validation. So you could have validation logic built into the questionnaire, so that if the user doesn't answer the question in the correct way or hasn't provided the data in the correct format, you will be able to prompt the user to correct that. And then on top of that, you will have sort of expressions you can use to automatically calculate some of the answers to to the questions. Here we have a example questionnaire. On the right, it's a very basic JSON format, but you can see that there are 5 questions defined in the questionnaire. Each of them has a text, the data type, whether it's required, maybe some additional information on how it should be formatted, or the constraints on value. So now I'm going to give it back to Francis to really quickly talk about extraction and population.
Cool. So just to take you one slide back. So you see from this FHIR questionnaire, you have like various sets of items that are presented in them, which essentially will be the different questions that ideally you're going to interview the different respondents in order to collect your data, and then be able now to ideally format and store it in now the different resources that you'd want to use to store the different clinical artifacts for the patients that ideally the CHWs will be looking after. So with this, the whole idea is, how do I go from rendering this questionnaire, which is in JSON form or XLS or CSV, onto a UI? So the structured data capture library will help you to ideally get the questionnaire as a JSON and then render the different widgets that ideally will be used to collect the data. So if you're doing open text, Boolean questions, you're doing the drop downs, the SDC library will essentially be able to provide you a way in which it will consume the FHIR questionnaire and then be able to render the different widgets that will be useful to you to be able to capture that information. And then from there, we have, I'd say, 2 main operations that ideally would be useful for the different implementers. That is, 1, population, and 2, extraction. So we have 3 main forms of population and extraction. One is the observation-based, definition-based, and structure map-based. So these ideally would, as given there, give you the lowest to highest level of flexibility, but then also start from the highest to lowest level of simplicity when you're using the different forms of the extraction or population. So in a nutshell, some of the differences between the 3 forms of extraction and population would be at high level. In an observation-based extraction, you're basically looking at one-to-one form of extraction. And also this ideally will work for only one type of resource, which is the observation. And then the definition-based will again work one-to-one, but now extends the flexibility of not just working with observations, but now working with the different types of resources. And then we move to structure map-based extraction, which now ideally will be a one-to-many form of extraction and also provides with you the flexibility of taking the various forms of the questionnaire responses and generating multiple forms of resources based on your data collection. So when you're moving from, again, data collection to also rendering. So you use the extraction to be able to move from the questionnaire response to the different resources. And then you use the population to essentially now get the questionnaire response to render back the responses that were ideally collected in the questionnaire response back to a form. Then when you move to authoring, we have various tools that are currently there that provide a form of GUI to be able to help the authors to create the forms. So some of the most popular ones that we use are either the form builder from LLM or Hasselnog to be able to help the different authors. So these provide different forms of functionality, but then depending on the usage, actually when you go and try to use them, you'll find that both of them are very similar in the way they do the authoring, but provide different set of functionality and flexibility when you want to use, let's say, different form of widgets, how to be able to go about providing validation, or even in the more extensive usages, how to add now the codable concepts or even the FHIR path expressions to be able to provide for you validation. So these two tools provide a way for you to do that. So next, you're going to see how the Android FHIR SDK implements the SDC library.
Thank you. So this is all very well that we have the standard that defines everything, but we still need to implement and then apply the standard in a healthcare application, right? So we have built a library on Android to help you do that, to implement the SDC standard. Obviously, there's many different libraries that act as form fillers, such as, I know there's Firefly on Flutter, there's other loads of very useful, very cool tools. So really depending on your platform, but if you're on Android, we have this implementation that does this thing specifically for you. So basically, if you import the library into your application, hello? You can, so the library will does most of the heavy lifting for you. You will translate a FHIR questionnaire we have authored in one of the authoring tools we mentioned to an Android UI. So it really saves you from writing a lot of very sort of laborious kind of Android code, right? It saves from having to fix the UI bugs, because in the library, if we have good testing, we have good community, we make sure the library is of high quality, then you don't have to deal with UI, Android UI coding, which is quite painful, frankly speaking. It captures the answers in the questionnaire response, and then supports some of the rendering options and the advanced form behavior we mentioned just now. And it also supports extraction and population. Right, there's some developer resources. Feel free to go to our dev site. You can really, it's all linked from the OHS dev site, so it's easily discoverable. So with that, I'm going to pass back to Francis to give us a demo on OpenSRP's implementation of SDC.
Cool. So I'm going to do that. So ideally, as we prepare for the demo, what you see from the showcase is how do you go from moving from to be able to ideally find ways in which you can be able to collect the data and then implement it in the different use cases. So as an implementer, one of the things that you're trying to do and using the SDC and the spec is to be able to move away from like thinking about how I'm going to actually quote unquote think like the CHW, but actually help them by making sure that the capturing of data is very smooth, and also be able to add on to other specifications such as the expressions validation that will be able to improve the quality of how the data is captured and ease of also how the data is being collected. It's going to pop. Cool. So I'm just going to show a very simple example of how you're using the forms, and also in this case is a very simple application doing electronic immunization and how you're using the spec for either data collection or validation. So here I can be able to go and pop a question. So this is a form that is used to collect the data about the caregiver who ideally is taking care of a child. So you can be able to use the specification to provide for you ways in which to enter the data. So in this form, we have also extensions for required fields, which have already been added. You also have different widgets captured. So in this case, we have a date of birth that can be able to, date of birth input widget that can be able to use to collect the DOB about the patient, or be able to switch that to just enter the DOB as an integer. You also have different widgets provided here for collecting information about, let's say, record GPS, etc. And then from there, you can also be able to use, in this case, in the SDC population. So assuming that the data about the patient was collected, you can be able to use that populate function from the SDC to be able to get data from the patient resource and then back to the form to be able now to edit in this use case, for example. And then after that is submitted using the update function, you can be able to go back to your questionnaire response, extract back the data, and update the previous patient resource that was given for that particular patient. And then, of course, more widgets for submitting, discarding, validating the form, or even expressions to be able to give you estimates of date of birth, or even validate mean marks for the different entry fields that are there in the form.
Thank you. That's our talk on SDC.
Thank you.
Okay, great. Thanks, guys. The next lightning talk is going to cover some security and privacy and access controls. Bashir, do you want to use your laptop? That's all right. You can use, yeah. Thanks. So just a reminder, if people want to, I saw there's some questions coming through, so that's great. If you just keep asking your questions, and we will hopefully get to it.
Okay, hi everyone, I am Bashir. I'm a software engineer on the Open Health Stack team. And this is presenting, I will talk a little bit about security issues when you're dealing with FHIR, and then more specifically talk about one of the components that we have in the Open Health Stack, which is the FHIR Info Gateway. And let me also set up my timer such that, you know, if I can save a few minutes as we are behind. So there are several things that are considered when designing the resources in FHIR and also the operations that are in FHIR. And they are all, you know, gathered together in this FHIR security page. But one of the very first things that it says on the page that, you know, FHIR is not a security protocol itself. So it's basically the responsibility of the implementers to deal with security issues, although there are things included in the FHIR design that makes it easier. I'll talk about some of those, but there are also standards around it, like, Smart on Fire, which tries to, some of the scenarios that are very common and relevant, it tries to address the security problems around those flows as well. But again, it's not the core of the FHIR. So it's basically a common problem whenever you want to implement, especially, dealing with healthcare data, you want to make sure that, access to healthcare data is actually protected. So some of the common problems and, the way that, I'm going to reference them in this talk. So for example, when someone is accessing the data, first of all, you want to know who the person is, which is the problem of authentication, very common in many systems, not just healthcare or FHIR. And then you want to know this person that now I authenticated, what do they have access to? What are they authorized to access to? Which is the problem of authorization. And then you want to make sure that, okay, now what they are requesting, the FHIR request that's coming in, it's within the access that they have. So it's the access control problem, basically. And so there could be more fine-grained questions like that, like in general, health workers have access to observation resources, but like HIV status is a protected status, and then I want to, this is a specific observation, only certain people have to have access to that. For that, again, you have like something like security tags. Again, in FHIR, you can attach to resources, and then you can interpret those. Another question is that, if someone wants to give consent, such that, their healthcare data can be used for research purposes, how can I make sure that, that consent has explicitly been given, or that's for that particular organization, that's, the consent resource. And if you want to have some sort of data governance, making sure that, access to data is actually logged and monitored, you need to do, solve the audit problem, and you have audit events, again, another resource in FHIR. So as you can see, there are like, pieces in FHIR that can help you solve security problems. Okay, now, as this is just like a lightning talk, I'll try to focus on just 3 problems which are kind of related to each other. And that's authentication, authorization, and access control. Who the user is, what are they authorized to access, and then how can I enforce that, basically. Okay, so the problem statement, this actually, the way that, we design and develop the FHIR gateway came actually naturally out of the interactions with the partners who were using the Android FHIR SDK. So they wanted to develop like an app, and that app needed to talk to a FHIR server. And basically we wanted to make sure that whoever is using this app is authorized to do what they are trying to do. So a very common example is that you have a mobile app or you have a web app that talks to a FHIR server. And then basically, as I said, the question is that, who is using the app and what do they have access to? For example, it could be like a health worker using the app to access their patient information. Or it could be like a program admin, using a dashboard or creating a dashboard basically to monitor their program. Or it might be like the patient himself or herself that they are trying to actually access their own data, or the parents of the patients, like if the patient is a minor, they want to access their data. So it could be a patient-facing app. And even it could be like backend components, like we have like the analytics component, which we will talk, we have a session in the afternoon, a hands-on session. And that will basically is an example of a backend component that talks to the FHIR server. And again, for that, you want to make sure that, that backend component is authorized to access what they are accessing. But, that I wouldn't go into the details of that specific use case because it's a little bit different authentication and stuff like that. So as I said, that's how the FHIR gateway was born out of these requirements. And what the FHIR gateway is that it is basically like a FHIR facade that sits around your FHIR store, and that's where you implement your access control. So it's like a FHIR server itself, but it's specifically for access control. So your access control logic is being implemented there, and then you can put this in front of any FHIR server. So basically we are separating the question of FHIR store itself from the access control, and you can put it anywhere basically. Okay, so the general architecture, and this general architecture is not specific to the OHS FHIR gateway. It's like a general structure, but in this context, I can talk better about what's the role of the FHIR gateway. So the problem of authentication, like I said, is a very, very common problem. And there are even like, generic services like, Google, those sign in with Google signs that you see in many websites. That's the authentication. That's, a service that solves the authentication problem. So that IDP or that identity provider is a very generic service. You can even, design a healthcare system that, uses a generic identity provider. And then there is the problem of the authorization. And for that, again, as I said, this is a common problem. It's not specific to healthcare. There are open source tools for that, which again, we don't need to recreate. And a common example is Keycloak, for example, that you can implement the different flows that you have with OAuth and stuff like that. You can use with Keycloak. And Keycloak, by the way, there are like a smart extensions for Keycloak, which is related to that smart and on FHIR that I talked about a little bit. And then basically what happens is that the user comes to the identity provider and the authorization server. They identify themselves and they basically get a token from the authorization server. And with this token, they can come to the FHIR server and they say that, because I am such and I have such and such access, I want to execute this FHIR request, like this GET or this POST or whatever. And that's where the FHIR gateway comes into the picture, basically. So we want to make sure that, the FHIR queries that come in with the access token that is attached to those queries are correct, basically. So they are within the access that are provided in the access token. And we don't make any assumptions about the client app. We just rely on the access token. The actual meaning, what is the access what is the access boundaries for a person could be coming from anywhere. It could come from a third-party service. It could be kind of coded in the FHIR store itself. For example, in the patient resource, you have a general practitioner field. And if the user is a healthcare worker, you could say that, they have access to all patients whose general practitioner is this user, basically. So it could be kind of indirectly encoded in the FHIR store, basically. Yeah, let's skip this one. Just talks about the being a stateless. Okay, so some of the design principles that we had in designing the gateway. So we wanted, and these are in the design doc, and that's the way that they are being referenced in the design doc. Design doc is also available on the Git repo. So we want the access control logic, the core access control logic, like that general practitioner example that I mentioned. We want that to be very flexible. So that's basically like a pluggable architecture that you can plug in any access control logic that you have. We don't make any assumptions about the app. So we actually assume that, because in some cases people may assume that, because I trust the app, then I know that, they are going to use the access token in such a way, but we don't make any assumption about that. So even, if they are trying to abuse the access token, we want to account for that. And like I said, we want this to be deployable in front of any FHIR server. So basically, if in one of your implementation, that's actually a real example that we have with one of the parts. I think ONA has a use case like this, that in some cases you want to deploy your access control in front of a happy FHIR server. In some other cases, you may have like a GCP FHIR server. Is that correct, right? You have like a GCP FHIR store, but you have a similar, access control logic that you want to use. You just deploy the same service in both places. Okay, so now let's dive a little bit into the tools that that is available when you are creating your access control logic. probably the most important piece that is available, and that's what the FHIR Info Gateway actually provides, is enforcing patient access. So a very common pattern is that the user may have access to a set of patients, like one patient or a set of patients who are their patients, basically. And then you want to enforce that the FHIR queries that come in are all for those users, basically, for those patients. So they are not touching information of any other patient. And that's basically, so we rely on the patient compartment definition, which is like a FHIR concept again. And so the patient is at the center, and then for different resources, there are references to the patient. And you could say, because this user has access to this patient, then they have access to all of these users, all of these resources that are for that patient as well. So that's probably the most important piece. And then you have other things. You can define certain query templates that you would say that, I trust these query templates, and there are reasons that, you trust that. You may block some of the queries. Like, for example, there are some sort of joins in FHIR, like, chaining and reverse chaining, which by default be disabled because it's hard to enforce that access logic. You can rewrite the query. So when the query comes in and then it wants to go to the FHIR server, you can add things to it. You would say that, I want this security ad also to be added, or this patient to be added as well. And then when the results come back from the FHIR server, you can post-process it. So you can make changes to that resource before sending it to the user, to the client. I can skip this one because of time. Yeah, and then these are different pieces of code, like the libraries that are provided in the Info Gateway. Maybe I can just finish by one example. So let's say you have the user has access to one patient, let's say PID, and they ask for patient/PID. Of course, you grant access. And then if they ask for an observation, so let's say an observation ID, then it's up to you in your access control logic. You can either deny, which is this second case here. You can say that, I deny access to this because at the time of the query, I don't know whose observation this is. You are only allowed to access patient PID. I don't know whose this observation is for. Or you could fetch the observation, inspect it after it's come back, and let's say, oh, this is for PID. So then I let it go back. If it's not for that patient, then you deny. That's another approach. Or you would say, you should tell me who the subject is when you are accessing. So these are different ways to deal with these patient boundaries when you are implementing your access control logic. Let's skip this. This is a real-world example, which ONA. We have been actually work closely with ONA on implementing their access control. And some of the examples here, like the sync strategy, for example, is that so the requirement actually came because of the needs that ONA had, for example, and we think it's actually a common need, that there are queries that are not a standard, so they are like custom queries. For example, you want to sync with the FHIR server and then fetch all of your patients in one go, for example. And these are the things that, again, you can have custom endpoints implemented in the gateway. Yeah, and we have active developer community. Please feel free to join our calls or the mailing group. And sorry, I went a little bit too fast. If there are questions, I would be happy to answer at the end.
Okay. Yeah. Thank you. How's everybody doing there? Are you still awake? Great. Maybe just do a quick stretch. We're kind of at what the original lunchtime was, but we're just trying to catch up a little bit. I think we're making pretty good time. Yeah, so our next lightning talk, just a reminder, thanks to the people that are putting questions in there. What might be really useful, if people want to take a look at it, then you can upvote, and then we'll try to at least cover, some of the most voted for questions before we get to lunch, okay? And then we'll try and cover some of the others another time. Great. All right, so inviting Richard Langford and Aisha Hassan to give us a talk on approaches to integrating with FHIR, Introduction to Mapping. Thanks.
Can I use my laptop? Is it all right?
Oh, yeah, sure. You want to do it? Yeah. Okay. Just while Richard's firing it up, so thanks. We've allocated all the breakout sessions. I'll wait till the end. Just at the end of these sessions, I'll send out a quick email to everybody. And then if somebody hasn't got a session, and we'll also introduce like who the session leads are. And if someone hasn't got the email, then you'll come and find me. Okay, Richard.
Thanks, Fred. Afternoon, everyone. My name is Richard Langford. I'm from Jimmy Health Systems. I'll just hand over to Aisha quickly to introduce herself.
Hi everyone, my name is Aisha Hassan. I am from Open Function.
Great, thanks, guys. If I start looking at you and my face, my eyes start squinting, I'm just starting to get this seriously big headache. It's not because I don't like you, it's just because I've got a headache. All right, just in case I look at you funny. So kind of just diving into an introduction into mapping, I think there's been some really great presentations thus far, which really leads up to how one can leverage mapping to support interoperability. I think it's quite a common challenge in many healthcare settings. So maybe we can just dive into it. Just a quick donor acknowledgement for Jimmy Health Systems. So Jimmy Health Systems would like to acknowledge and appreciate the ongoing support and generous funding coming from CDC's Technical Assistance Partner Program. And going straight into the first presentation or slide. Okay, so first of all, mapping, why do we need it, right? Interoperability. I mean, there could be several, I think it's quite common having several organizations out there, still hospitals, running legacy systems, and now there's a requirement for them to become more interoperable with FHIR compliant systems, right? So there needs to be some sort of data transformation with regards to that. And when we start thinking about data transformation, non-FHIR systems can use varying formats, right? JSON, XML, some systems could implement some level of format, say, JSON could be across 5 or 6 different systems, but the structure of that is now completely different. So there's no compliance, there's no real standard way of actually solving problems when it comes to data. So data transformation is quite important when it comes to the format and structure of your messages. Enhanced data sharing. So when done appropriately, you can actually, and through the use of sharing personal health information, you can improve care coordination, very importantly, reduce duplication of tests, and of course, enhance patient outcomes. And cost efficiency. There's been some great talks leading up this morning up until now. FHIR is not saying, I'm going to make you go and change everything, right? Because then we're doing something wrong. What we're saying is you can continue to doing what you're doing, but let's see how we can leverage capabilities like the FHIR structure map resource. I'm talking specifically in the context of FHIR, together with concept map resources, together with logical models, so we can help solve some of these problems so that you can become more interoperable with FHIR compliant systems. And then just looking at some common data transformation use cases. So non-FHIR to FHIR, I think that's something most of us have seen quite often. So I've just got some basic example here. Well, I just call it some standard. We are going to be talking to some examples in a breakout session. We start talking about the CHT patient registration process. So I've just kind of added a little JSON snippet here, what the proprietary or the standard that they're using to represent the patient registration data elements. And then what this looks like when it comes to FHIR. I'm using some elements here with, describing it through FHIR path. I'm not going to go into detail about that right now, but, oopsie, sorry about that. But here we can see from the top down, ID, name, phone, date of birth, proprietary, and versus what FHIR is actually expecting. And one example, of course, is, other than CHT patient registration, ComCare patient to FHIR patient resource is another example. And then from one resource to another, and we've seen quite a bit of this coming from some presentations where you want to have data that's perhaps been captured in a questionnaire response, and you want to have that converted to a more specific resource, like an observations resource. Maybe in your questionnaire, you might say for breastfeeding status, you've captured a yes or no, but in particular in this example, let me rather keep it as yes, which is either true or false, or yes, no, how they're captured in the form, how they represent it. But there's a specific loin code or SNOME code or whatever that actually represents what that answer actually truly means from a more standard terminology point of view. So you can actually capture this information and put it into an observations resource if required. And And then looking at varying FHIR specifications. So what that means is you have like a FHIR R5 FHIR specification, you've got a FHIR R4 specification. And what I was trying to show you is that we have both specifications have a care plan resource. And what I was trying to do is capture the activity details about this care plan. Or in other words, a patient may be enrolled into an ART program, they're picking up AAV regimen, you need to get the next ART follow-up date, and so on and so forth. Now, you want to capture a lot of this information when it comes to activities. Some of the things I've just described might be extensions. I'm not going to get into the weeds of that right now. But what I want to show you is in the FHIR R4, activity.reference. In FHIR R5, activity.planned activity reference. So there's already a difference between those two FHIR specifications, and there's already a room for potential data transformation. And then another one, which is actually going to be quite challenging, and I think Jose touched on this quite a bit earlier, is implementers interpreting data requirements in their own way. So they kind of, we have one implementer or author trying to do something one way, and then another author, an implementer does something another way. Now you've got two basically implementations trying to solve the same problem. Now when you start implementing a larger ecosystem, this one's saying, I've got apples, this one's saying, I've got oranges. Where do you store this information? Now you're not going to just solve potential, maybe even FHIR version issues, but now inconsistencies between different FHIR implementations. I mean, that's quite a common challenge. You have countries with kind of smaller ecosystems, depending on how it went about, who funded it, who was doing what, these things happen. Now suddenly you want to start connecting to a large ecosystem. You might run into these problems. So having the consistency in terms of appropriate data mappings, appropriate use of specifications, where the importance is having clearly defined data requirements, that is probably one of the biggest challenges, I think, in this space right now. Then looking at some FHIR mapping approaches. So what's quite common, I think, historically, if I can say that, is using mediators, right? You have your interoperability layer, and you create custom mediators where you transform your data and then you orchestrate it off to the various registries. And you also have things such as data transformation tools, which Aisha will introduce a little bit later, where some of these tools, at least as of late, provide like a user interface, right? Where you can actually drag and drop. Some of it, much of it's completely no code, but there's a way to drag and drop and actually simplify the process, or at least reduce the complexities of having data transformation completed. And then, of course, the FHIR structure map resources. That's something that I'm going to be talking about a little bit more into detail in the breakout sessions later today through some examples. I'll show you a live demonstration of how this really works. But what you can actually do, you can implement structure map resources, which is very complicated, as Jose said. I mean, I think I've been involved with structure maps. I had to rapidly figure this out in about 3 or 4 days. So I was quite quick with that. And it is very tricky. Once you get into it, I think it kind of flows a bit easier, but you can make mistakes quite easily. Structure map resources are unidirectional. We will see some examples of some directions shortly. What that really means is that if you want to have a forward and reverse transformation when using a structure map FHIR resource, you're going to have to implement 2 structure maps to support that process. And of course, as we've heard a little bit earlier this morning as well, you can create a structure map resources using, or at least artifacts using FHIR mappings language. If you really wanted to, you probably could use FHIR shorthand as well to create this, but I would probably recommend trying to stick with FHIR mappings language, in my personal opinion. And then looking at some of the common data transformation flows. So unidirectional, I kind of try to wrap this up with push and pull activities, or at least operations. So unidirectional, maybe an EMR, and you want to just send data to some registry. That's it. That's the job of that system, just to send information, and this information is going to be reported on or what processed, however that's done, doesn't really matter. You just want to send this information into some registry. And bidirectional, I like to see this as a system, maybe an EMR, where you will send your data out, where it gets persisted into some registry, but then later on, you want to get the information back. So you're going to have forward transformation as well as reverse transformation when you start looking at bidirectional transformation flows. And then omnidirectional, which can be a little bit more complicated, and I haven't really seen any implementations as such specifically with regards to this, but you might have a situation where you have data being sent into your health information exchange, and then your data is fragmented into specific registries. It could be synced into other registries based on the type of data that's provided in FHIR bundles, Several use cases can really describe how this data actually really flows, but they could be fragmented into different registries. And then later on, when you want to get this information back, you need to then consolidate this information and send it back to the system who's actually requesting this information. And then choosing the appropriate FHIR server. So we heard a little bit about FHIR facades this morning, and I think, well, recently as well. So for me, a FHIR facade there's no data store. That's the first thing you need to remember. You can't store data in a FHIR facade. It's basically a bridge between a target, a source, and a target system. So what that really means is, on demand, there will always be data transformation. With every request going in and out of that exchange, there's data transformation going up and data transformation coming back down when you want to return this data back to the system. That could create latency. That could add some complexities with regards to your implementation. Just something to really keep in mind. And also, we have the full FHIR server, otherwise known as the native FHIR server. So what that really means is you can actually have a FHIR implementation where you have your FHIR data store. Say your data store could be whatever you design your data store be. But I mean, quite popular, I think, lately is that you're using a data store for a shared health record, for example. So what that really means is you can have your native FHIR implementation of a FHIR server where you have systems who talk with FHIR resources, right? Or you can actually further that, maybe have proprietary implementations of data structures where you can still continue to use a structure mapped resources to transform some of the data coming in. And then again, of course, when you want to return it back to the server where you're doing bidirectional transformation, you can do that as well. So you can have FHIR compliant to FHIR compliant, or you can even have non-FHIR compliant to FHIR compliant, and vice versa, if you wanted to with FHIR facade and FHIR native, just to be clear. Thank you. That's it from our side. I'll hand over to Aisha now for some FHIR mapping considerations.
The scenarios are going to have one activity in common, and that's going to be the mapping activity. So from our experience at OpenFN, I just want to share a few insights that we have or considerations that we need to take when we're doing these mappings. The first thing I want to mention is around having a clear data dictionary. And what I mean by data dictionary is if, for example, if we take an example of an EMR, that's non-FHIR. It's going to talk about a visit case, and we're going to be capturing a lot of like data elements around visit cases, like, for example, when a child was put to breast or head examination. And these are going to have to be mapped to a FHIR resource and an appropriate LOINC or a SNOMED code. And one way to do it is to have a data dictionary that maps these data elements to their appropriate FHIR resource and appropriate terminology services. So we need to be able to define these accurately, and if not, then it's going to lead to like erroneous data that's sent to FHIR. The other thing that I want to mention is being flexible to be able to modify our source application. Sometimes we might not be capturing all the data element that are required to be sent to a FHIR resource. So we also need to be flexible in regards to being able to modify the source application to maybe capture some of the forms or even store those data dictionaries. So those are the other considerations that we want to highlight. One example that we have is we had this ComCare application that was used as an EMR, and we used or leveraged the lookup tables in ComCare to store these data dictionaries. So what we were doing was storing those option sets and their mapping to a LOIN code in a lookup table. But then our workflows would be reading from that lookup table and making those entries or creating those FHIR resources based on those lookup tables. So that was one of modifications that we had to do in our source applications, but I understand that it's not always possible to do it. So when and where possible. The other consideration is around selection of FHIR resources. So we have to be very careful when trying to select these FHIR resources. We don't want to just overload one FHIR resource. We don't want to add a lot of extensions in the patient resource to include the visit information. We have to leverage the modality of FHIR and make sure that we're creating the appropriate resources for the appropriate use cases. So patient data for demographic data, patient resource for demographic data, encounter for visit information, observation for clinical data. So we have to make sure that we're using the appropriate resources, and sometimes this might require some FHIR expertise. So it would be best to consult with FHIR experts for this as well. The other thing I want to mention is validation and missing data. So data quality is very important in healthcare. So we need to make sure that we have validations, rules, and automatic checks in place. Incoming data coming from our EMRs need to be checked to avoid that we don't send missing data or invalid data to our FHIR servers. Similarly, for missing data as well, we can have like an automation or like a process configured to make sure that we have a system in place to compile those records that have missing data or invalid data and notify the admin. This is as much as business process as it is like a technical problem. So we need to also pause and think about how we can automate that business, right? We want to make sure that the admins are notified. We don't want to disrupt our pipeline. We don't want to disrupt our workflows. So to ensure that we have to think about the business aspect of it as well. And yeah, make sure that we have these processes in place. Yeah, and then finally around process optimization, yeah, we're gonna be mapping, like for example, a single visit case to multiple FHIR resources, and we're gonna be making a lot of requests to our destination FHIR systems, right? So we wanna think about how we can optimize this performance so that we don't hit a lot of API throttlings. So one thing that we can do is take advantage of FHIR bundles or maybe batch our requests, but this is something that we also have to consider. Maybe we have to do a lot of load tests, but very important considerations here as well. The other thing I want to mention is around error handling. As much as we try to avoid it, failures are gonna happen, but how we deal with failures is what's important. We need to make sure that we have like this process of retry, but without having to create multiple records all over again in the destination system, right? So we have to consider the item potency and having unique identifiers to make sure that we're not creating the same records over and over again every time we retry. And that's something that we have to be considering in our mapping considerations. They're telling me that I'm done, I'm out of time now. But yeah, I'm gonna leave you guys with this slide on other tools that are known to support data transformation, and thank you guys. Oh, we'll share the slides.
So let's put it back on.
It's like I'll pop it up. For our final lightning talk, Patrick and Moses from University of Washington on FHIR analytics. I'm just going to find you this one. Yeah. No, it's okay. It's okay. Don't worry. Okay.
Hello, my name is Patrick Prado. I am from University of Washington, Digi, and we'll be presenting on sort of the analytics. I will be going quickly through it, and if you all are going to be joining our session later with FHIR, we can talk more about like technical implementation and how we're sort of achieving some of this work. Oh, thanks. Okay, analytics on FHIR. So what are the problems we're trying to solve? Quickly, I think you've heard it before. JSON or XML, if you're using that in FHIR, is excellent at storage, excellent at representing real world data, and human readable, right? You can read that gender, various names given, various telephone numbers given, but harder to retrieve data efficiently and quickly, and an analytics burden. So the need to parse an entire tree if you're going to get data out of the system. So our current reporting structure. So, you know, I think a lot of our environments are similar. Multiple data pipelines are expensive to maintain. There are inconsistent reports and resources spent towards replicating reporting in different program languages, platforms, and systems. And so that also means that a lot less time is spent on stuff like quality assurance and data use. And here's our colleague from Zimbabwe. just doing some dimensional modeling using open FHIR pipes. So in order to coordinate our processing, it's basically 3 steps. The first step being to flatten the tables into a columnar format, so moving it from that JSON or XML format into a more table-like format through Spark SQL statements, SQL on FHIR v2. The second step is dimensional modeling, and then the third step is the use of centralized dashboarding, reporting, and monitoring of data and outcomes. So what are the advantages of this approach? Sort of a single source of truth, a consistent and standardized operationalization of FHIR resources, which allows us to share scripts across different implementations. Because we're using a similar FHIR model, we can use similar solutions, and ultimately reducing time to implementation. And of course, the use of Apache Spark. So future-proofing solutions through right out of the box, handling things that we're going to need in the future, right? When we're scaling up, horizontal scalability, accommodating changes in the workflow, fault tolerance, et cetera. So in terms of implementation, I'll quickly walk through some current methods that we're using for Zimbabwe and Cote d'Ivoire. And these are steps for table flattening, dimensional modeling, and dashboarding, along with some future concerns. So step 1, as I mentioned, is creating a flattened columnar table, right? So 3 things there are mainly 3 different methods and things to consider: standardization, flexibility, reusability, and expressiveness. So and we can go through more of this later if you are in the technical session. Spark SQL, there's one basic function, the explode function, where we can have multiple nested data become multiple rows in sort of a long table structure. There is, as you've heard, FHIR on SQL v2, which is more standardized use of FHIR path queries. And we can use something like the for each function in order to flatten these tables. And then something you'll hear about later also, WHO CQL indicators, which will give us, and here the basic model is we have a standardized FHIR model, which you are mapping your data to, and then we are allowing the CQL to basically calculate the aggregate indicators for you. So this might be better if all you're concerned about is the aggregate indicators. So step 2 from just flattening the tables is dimensional modeling. So how do we standardize approaches to ensure consistent operationalization? And again, we can go through more of this, but basically it's a bunch of fact tables surrounded by dimension tables. So if, for example, you can have for FHIR a treatment table that's surrounded by a patient dimension where you're basically rolling up or dissecting through various variables in the patient dimension, like gender or age, facility dimensions in case you're concerned about location, and then maybe reporting dimensions in case you want to map from calendar year to CDC reporting years, et cetera, et cetera. And basically it's integrating and transforming you already flattened the tables and you are integrating these various resources like observation resources, patient resources, medication dispensation resources. This is for FHIR, even appointment resources, and you are flattening that into one treatment table. CQL, you take a slightly, as I mentioned, different approach where you are taking your FHIR store and you're using structure mapping in order to transform those FHIR resources into CQL compliant FHIR resources, and then you're using that engine to create measure report resources. That measure report resources contain aggregate counts of each of the individual indicators that you're interested in, and then you can go ahead and flatten and using FHIR pipes to sort of achieve the same dimensional model, which is basically like a flat, again, fact table. This is for FHIR, where you have aggregate numbers by each of your reporting date dimensions and each of your facility, which are your location dimensions, to be able to report and drill down across various dimensions. And so the last step is being able to plug this all into dashboarding for visualizations. And so this is an example of a dashboard that we've co-developed with the Zimbabwe team for TX-Cur. So it involves loading and linking tables in a star schema, use of DAX for measures and visualizations in order to aggregate across these reporting periods, and then also developing these visualizations and leading data use activities. So some final thoughts as we're moving through the solution, but this is invariably going to create lots and lots of SQL scripts. How are we going to orchestrate, manage, and coordinate these various Spark SQL scripts in order for execution? How are we going to future-proof this process? So the same way that this is horizontally scalable, right now we're using a batch rebuild strategy where we're just basically like wiping everything away and then rebuilding it again. But how do you change that to more of an incremental update strategy to improve performance? And then also communities of practice, right? This is sort of, we started this conversation at OpenHIE, and how are we carrying forward this conversation as we're all supporting different aspects of the solution. And so here's our QR code for joining a community of practice if you are interested, and I think that's it. Thank you.
Thank you, Patrick. Okay, well done. We made it. I think we managed to get a little bit of time back. So I think what we're going to do, I know it's lunch. Lunch is going to start at 1:30. So thanks for the questions. We have these like Ask Me Anything sessions on day 3. So we have, I suppose, 2 options. We could spend 5 minutes trying to run through a few questions now. I just want to do a bit of housekeeping for the breakout sessions first, or people can stay back for a little bit, or we can some of those questions who are specific to the speakers, we can try to find them during lunchtime. So why don't we just run through this quickly, and then if we have a few more minutes, we will pull up some questions. So I think everybody should have completed their breakout sessions. I just want to, before everyone runs off for lunch, I'm going to drop you an email during lunch that will tell you which session you've been in. Basically, everybody got the first session. Some people put 2 first sessions, but you got one of them. I just want to maybe introduce, you should know some people, but Jing, do you want to just stand up? So Jing will be in the Kifaru room. I'm not sure where that is, but there'll be some signposts there. The FHIR mapping, so maybe Richard, you met Richard already, Alexa, and Njunga from Medic. Is someone just trying to stand up for a second just so people can see you? So just Alexa as well. So these people will be leading that with support from others. I'm just calling them out as the point of contacts. And the email that you'll get, if you have any issues, you can reply back to me or to them. And then on the analytics side, Bashir and Patrick and some others there as well. Okay, great. Now, let's try and show this. Okay. So first, I'm just going to, sorry, I can't present this, but you can see this here. All right, so these are some of the questions. So some of these I might actually suggest, like for example, the performance question, Grace, we bring that to some of the FHIR experts. We have, as I said, Diego and Graham are going to be here on Wednesday, and I think that's a general kind of question. Is that all right? Where's Grace there? Great, thanks. Okay, maybe to Jing, or how do you optimally navigate the FHIR documentation website as a beginner?
I think the FHIR website is quite nicely laid out. Perhaps Jose will have some comments on that as well. But if you go to the main page, it's organized by different modules, and there's a lot of information. But try to like sort of go through the basics first, and then go to the more advanced topics. I would say one thing about this is that the FHIR documentation and website can be quite daunting, and I'm still myself very scared to look at some of the content. So just don't be too put off by that, right? Because that's a feeling that you will probably always have, because you don't really work with all the different corners of the FHIR specification. Even some of the FHIR experts like Jose, I'm sure there's some resources he's never touched before. So really just try to get to understand the basics and go from there. And I would say maybe another way to answer this question, what's the optimal way to navigate the documentation, I think is to use the community. The chat.fire.org site is very, very helpful, and people are really willing to jump in to give you advice and help you. So that's another really good resource to use.
The CQL question, we're going to cover CQL and some of that in a little bit more detail also on day 3, so let's kind of park that. Thanks, Grace. Maybe the latest question, can the FHIR info gateway secure a happy FHIR server, and how is this set up? Hand that to Bashir.
Yeah, like I said in my presentation, so the idea of the info gateway is that it can sit in front of any FHIR server, and Happy FHIR is probably the one that we have tested the most with. And the implementation that the first implementation, like the real deployment in production of the FHIR info gateway was in front of Happy FHIR, right? Is that correct? So yeah, definitely the answer is definitely yes. Oh, now how is it done? So the setup is basically, if you remember that architecture, is basically you need like entity that does the authentication and authorization. So that's the entity that issues the access tokens. And then every request that comes, every FHIR request should have that access token attached to it. The access token defines who the user is and what do they have access to. And that's the job of the info gateway to apply the access control logic. The way that you code the access control logic is up to the implementation. There are some prepackaged access control plugins, but usually people implement their own.
Okay, I'll take the next one. Yes, you will receive, we can share the presentations. Though actually all these recordings will also be made available, so you'll be able to go back over that at a later stage. All right, I think for our last question, some of the others will make sure that we get them into some of the other sessions. But in Sierra Leone, an application was developed using traditional systems that are not FHIR enabled. What strategic steps would you recommend to align this application with globally accepted standards? I'm going to, Jose.
Yeah, so this is a very common challenge. So FHIR is a technology for data exchange. So it doesn't mean that you have to change everything on FHIR. If you did it, if you have a lab system working on HL7v2, it's fine, it works. So first, making it work. But what strategic steps would you do if you eventually have the migration, the intent to migrate to FHIR, or just say, is this data future-proof? Is this data reusable? Check your specifications. Ideally, you should have the functional specifications captured. Most likely, you won't. The specifications of what the system is doing is buried in the code. So try to reverse engineer that if you need to. Check when we say standards, it doesn't have to be FHIR exchange, but it's useful to see, are the terminologies there? Do we have everything in place? Is this a RESTful API or something else? So try to see what you have. If it's working, keep it working, and get your analysts, your SMEs to see what is it supposed to be doing, document that, and then in 10 years from now or 10 months from now, you'll have a chance of saying, okay, this is the gap between what we have and the standardization version of what we should have. So that's a very common problem, and I think it's very important to handle it.
Yeah. Last comment. Oh, it's one over there.
This is related also to this last question, but also I think it was Grace who asked the performance question, right? So 2 points. One is about this last point, and then I'll come back to OpenMRS actually. So Happy FHIR, I guess many of you have heard about at least. So one of the common usages of Happy FHIR is the one that comes everything together with the JPA server. So you have the Happy FHIR and it has the database support and everything, right? So that's basically your FHIR server. But another very important piece in Happy libraries is the plain server, if I remember correctly. And that's where you want to basically to deploy it similar to this question. So you have some other data model for your healthcare data, and then you want to support FHIR now. You can start with that. So it's basically like a FHIR facade around your healthcare data. And that's how basically OpenMRS did this from several years ago, right? Now I wanted to come to the performance question because it's related to this. So when you do that, that's very good to start because you can provide FHIR API without changing your data model, right? And this is actually very good for starting and doing interoperability. But then, that was actually what we were burnt with when we were doing analytics on FHIR for OpenMRS. Every time that a query is made, you are making that mapping. So every time there is an overhead, which basically maps your data model to FHIR data model. And at some point, maybe you need to reconsider whether I should continue with the data model or should I gradually convert to FHIR as a data model as well, just to deal with the performance problem.
Yeah, thanks, Bashir. So I just wanted to comment on, just add more insight to Bashir's insight on security. So we've done several approaches to providing security to like a FHIR server. So one, we've done approaches where we try to implement the security mechanism within FHIR itself, and also probably like using a third-party authentication server. I mean, outside the server itself, with providing security mechanism within FHIR itself. One, if you're dev and you're comfortable with hacking with code, FHIR comes with some kind of interceptors that you can. Where you can write your own interceptors and you provide your own mechanism like best auth SSL within FHIR itself, right? The second option, FHIR is literally Java application that runs in like Tomcat. So we just play around with Tomcat configurations and then use SSL authentication, right? So that way you run FHIR, but then it uses SSL authentication to authenticate client requests, right? So the third approach is we've also, in some projects, used the info gateway, yeah. The other approach, you can use another like proxy, like OpenHIM, where all the requests just go through like OpenHIM. I think OpenFN can also do something close to that, so yeah. Then the other comment on Patrick's presentations. So in general, the FHIR pipes, well, I was supposed to stand there, but I just needed to stand there, right? In general, the FHIR pipes are mainly used for transforming data or extracting data from a FHIR-based server. It could be a JPA server or a plain server. I mean, any other server that supports FHIR, like OpenMRS, and then exports it to like packet files for secondary like data usage, like analytics and visualization. So initially, the FHIR pipes project was initially created as a solution to performance issues in OpenMRS reporting framework. So the concept is, as data gets huge and huge, then you start getting issues with really making use of that data. So that's why that's how we came up with FHIR data pipes project to really get a much more efficient way of using like FHIR data and stuff like that. Yeah, thank you.
All right, I think we'll wrap it up there. Please join me. Big thanks to all the speakers. Thanks, everyone. So just to remember again, this was just really to kind of, anchor around some of the kind of core concepts, get into some of the intricacies of how developers might be using FHIR, some of the capabilities that exist out there, whether it's Open Health Stack, whether it's OpenHIM, OpenFN, these things. Have an opportunity to now play around with some of that in the breakout sessions. So with that, we'll break for lunch. A couple of quick housekeeping things. As you go out, you'll be given a lunch card. You need to take that for the hotel to have lunch. As I mentioned, we'll send you an email straight away after this that will have which session you will be in. and we'll help you to find that. And I think we'll probably come back at around 2:15, I'm guessing. 2:15. Yep, 2:15. Okay, great. Thanks, everyone.